Hello and welcome to episode 18 of Cooking with Unity. This is your host Max Moreau, and today we're going to do some asteroid stuff. So, this is actually probably going to be a pretty simple project. I haven't actually done it in Unity yet, but Unity is well suited for an asteroids game. We've worked with rigid bodies before, and when you're dealing with asteroids, all your player ship has to do is just be a rigid body. What we haven't done too much before is we haven't done a whole lot of force manipulation. We've done a few with the gibs and with the jumping in our previous one, but most of the time we've been using rigid bodies for like the main character, but we've been largely ignoring the physics. This time we're not going to be doing that. So, what should we start with here? Let's start by going to our main camera and making the background black, because we're in space. We might add a little star field in the background at some point or something fancy, but for right now it'll just be black. I'm going to go ahead and create our directional light so we don't have to deal with that until later, or don't have to deal with that at all for the most part. So, let's just put this in the air somewhere. And let's start with cube, sphere, capsule, cylinder, plane. No triangle type stuff. Alright, we might import a little 3D model just so that we have direction a little bit better. Because the problem with all of these shapes is none of them actually have a direction. I can show you how to fix that. We'll just use some of these shapes in the meantime, and I may open up a modeler real quick just to bang out a pyramid of some kind. So let's make our ship. We're just going to do 2 cubes for our ship. The first cube will be the main body, and we're going to put this at 0, 0, 0, and focus on it so that future objects show up around there. And we're going to grab, what should we have for the other thing? Yeah, I guess just 2 cubes will do it. So now we have the second cube. So we're going to call this the ship, or player ship. And then we're going to make this one a child of the player ship. And we're just going to move it off in the Z-axis. And we're going to shrink it down. This is just so that we have an idea of where we're pointing. 0.5. Yeah, sure. 0.5, 0.5. And actually, let's just make it go forward a little bit too. We'll just keep this one at 1. And we'll just move it somewhere inside there so it looks like it's part of the ship. Alright, so we're doing asteroids. All we have to decide to start with is, do we do it top down or do we do it sideways? It does not matter in either case. I'm going to go with sideways just because our camera's already in position for this. So X and Y will be our primary play area, and Z will be into the screen. So I'm going to move this to 0 just because I like it there better. The reason this thing defaults to 1 is just in case you're making it's so that if you create a plane, you'll see the plane. If this was at 0, when you create a plane at 0, 0, you won't even know it's there because it'll be right in line with the camera. I'm going to call this the cockpit. Why not? So we have our player ship. We're going to rotate him so that he is oriented the way we want. So yeah, we'll just do -90 here. And so now we have our ship, and that's that. Here, we'll hit play and see what we got so far. Not a whole lot, right? So there's our ship. Really ugly looking ship. We're going to want to replace that, but we'll go with this for now. I'm going to go ahead and save and name the scene. We're just going to call it main game. And let's see. What should we do first? Let's make our ship move around. So we're going to... Should I do this as 2 separate scripts or just as one? I'm just going to do it as 1 script for this time. So we're going to call this our ship. And open it up. And I'm probably going to have to move the window here once it actually finishes loading mono-develop. I didn't do this ahead of time this episode. Apologies for this. What we're going to be doing is basically creating a script that can thrust and rotate the ship, and it'll just have some parameters for that. And we'll probably just use the arrow keys for right now to do this. So here we go. Oh, was Unity on the wrong? Yeah, it was. All right. Everything's set up nicely now. Okay, cool. So here we go. This is our ship behavior here. So let's put a couple of variables in. Public float rotate speed. Public float thrust. Alright, and let's give some default values. I'm just going to use 1.0f, and I'm going to go with 100.0f. Hopefully that'll be meaningful. We'll be adjusting these values. I just don't want them to be 0 so that if we just didn't set anything, we still can see that it's working. So, let's see. All we need to do here is some physics stuff. So, in our update loop, we are going to check to see if the user has input some stuff. So, let's do the rotation. Let's do the thrust first because it's super easy. If input dot key get key, and this time we're not going to do get key down. We're going to just do get key because we want to know if the user is holding the key down. Up key code up arrow. So if we hold the up arrow, we're going to be adding a thrust. So it'll be, we're assuming that we need a rigid body. So rigid body dot add force, and then we're going to throw in just our force. So this will just be game object dot transform dot forward. This is the lowercase transform dot forward, not uppercase. There is a difference, though they both are incredibly valid, and so people can have some problems with that. Basically, if you do the it's vector 3 forward. Yeah, never mind. The other one won't compile. And we don't need anything else. Oh, yeah, we do. We want our speed in there, so we'll just multiply this by thrust, and I think we also want to multiply in time dot delta time, though we'll adjust that if it doesn't feel right. And what else? That's that for that. Rotate speed. All right. If input dot get key. Actually, let's try this first. Let's see what we got. So we're going to hit play, and it's going to think for a second, and we hit up, and a whole lot of nothing's happening. Oh, probably because we didn't actually attach this to the ship. So let's try that again. So hit up. Oh, no rigid body. We got the little error here. As I said, I had assumed that it had a rigid body, and it does not. So physics, rigid body. We do not want gravity, and I don't think we want any constraints either. We'll do more constraining with the code later, but right now this will be just fine. So hopefully this time it'll actually move forward. There we go. And it accelerates if I hold up, and it goes off the screen and it's gone. It's kind of acting a little weird, choppy there. I wonder if that's my computer. Well, working well enough. So let's get our rotation in there. So, if input dot get key right. Actually, let's do left. Not that it will matter. Left arrow. Alright, when you rotate this, what's the best way for us to do the rotating? So, we're not going to be applying forces for the rotating. Most asteroid games, when you hit rotate left or rotate right, you rotate while you hold it, and when you stop hitting it, you stop rotating. It's funny because they use half Newtonian physics because of this. The thrust is Newtonian, where energy is conserved and you will maintain your velocity unless you change it. But the rotational is just automatic, where it just stops you in your tracks as soon as you stop rotating. So we're gonna mimic that for now at least. We can always change up stuff later if we get bored. But so all we need to do is just rotate this thing. So what we're gonna do is, as a matter of fact, just to be safe. We'll do that if we need to. Go left arrow. So we're going to rotate this. So probably the easiest way to do that would be to do transform.rotate. And so what is this actually? Let's find out what transform rotate does real quick. So let's see. Applies a rotation. See, I don't think this actually. We'll have to keep track of the angle using this. I don't think we need to do that using one of the other functions though. Let's see what we got to work with. Let's try let's see. Vector 3 unity. Let's see what tools we have to work with here. Rotate towards. Alright, let's also check our quaternions. So let's do quaternion unity. Rotate towards. I think just rotate will do fine. I'm just going to see what happens if I set this to be a static thing. I think it's just going to be static, but let's do, what are the different versions here? Let's just do. Alright, so which way are we rotating this thing? We want to rotate it on its z-axis. No. Oh, yeah. It's because we already rotated it negative 90 here. Sorry, I'm just thinking about some stuff right now. We could put this in a container. Oh, I know what we can do. So instead of, let's get rid of this rotation, and let's put this. Oh, I know why we did that now. Huh. All right. Well, we'll just maintain. Well, dang it, this thing won't rotate nicely right now, will it? Little details here. Let me go back to that documentation real quick. Actually, let's just try it. Unity rotate over time. This is super simple stuff, and I'm kind of embarrassed that I'm not just belting it out right now. But let's see what we got here. Yeah, that's one of the ways we could do it, but that won't work unless we change the way that it's set up. These are not good examples. All right. Let's just do it the first way that they show there. Rotation equals. I'm just seeing what we got here. Yeah, let's just do transform.rotate. So we have a situation. I'm gonna go back to this in a second. We have a situation here. It's known as Gimbal Lock, actually. When you're dealing with Euler, and actually, I always call it Euler, and I'm probably going to continue to call it Euler because I have a nasty habit, and also because most people, when they read it, read Euler. It's actually Euler, I found out. So bear with me when I say it wrong, but I think people will understand what I'm saying. I'm saying the E-U-L-E-R word. So we're using Euler or Euler coordinates here, and when you rotate something 90 degrees in one direction, all of a sudden there's other directions you can rotate it in become the same thing. And that's known as Gimbal Lock. I mean, if you've seen, what was that movie called? Apollo 13. That's an easy one to remember. Apollo 13, they always talk about the gimbals and stuff. And what they're talking about is they have a method of determining their orientation in space, but it's actually a physical device that is done with concentric circles, kind of like, those spinny things that you strap yourself into at fairs sometimes. That rotate on 3 axes. That's basically what this is. But if they orient themselves in a certain way, they will lose one of the directions, and that's very bad because all of a sudden they don't know how they're oriented in space. And so that's what they're talking about there. So we're in that situation right now, and there's a multitude of ways to get out of it, but how I'm going to do it is just to start us with 0 and make it so the cockpit thing goes up, is just above it as opposed to in. So if we just go up like 0.6 here, oh sorry, 1. Oh, I see, we've got our sizes different. So we're just going to change the rotation here. Sorry about the phone call in the background. What are we doing? we're doing, we're changing this to 0.5, and we're changing this to 1. And 0.6 will be just fine for that. Alright, so now we have our player ship. It still looks the same, but now it has this little dealy bob at the top. And so now if we rotate it along the z-axis, it'll actually rotate the way we want it to. So, let's do that. Let's just rotate. Let's just see what happens when we just do 0.0f, 0.0f, and rotate speed times time dot delta time. Let's see what this does first. It probably will just rotate once and then not rotate again. But let's see. Nope, there it goes. It's rotating incredibly slowly. So obviously our default of 1 is way too low. Yeah, we're really going to want something. I think this is in degrees, so like let's do 60 or something. Much better. Alright, good enough for me. So, I'm just going to put this back to 60. And actually we're going to change, I'm going to go ahead and change that default in here too. It won't matter, but that was just too slow. And the rotation was actually opposite the way I wanted, I think. Let me just double check. So if I hit, so I'm hitting the left button here. No, it's working just fine. Alright, cool. So this will work. Though we want, now we just need to do right arrow, so we do the same thing, except for we do negative rotate speed, and that's it. And we make this actually right arrow. So we hit play, and now we should be able to, oh, this is going to be funny. I'm going to thrust in the wrong direction. So if I thrust right now, I go into the screen. And so that's kind of why I'd set that up the way I'd set that up earlier with the rotation in there. I'm going to set it back up. Maybe I'm stupid and it just automatically figures this out for us, but let's do that. Let's put the -90 back on here. And before I do anything, I'm just going to see if this still actually works. Actually, it looks like it might. Though we want to change which way it rotates this time. So let's try. I'm just going to change one of these. You probably don't have to follow along on this part at home because we're probably going to change it right back. And I did this on left, so I'm going to hit left and make sure that we actually get anything. Alright, that's actually doing what we wanted to do, I think. Yeah, okay, that'll work. Alright, let's move the cockpit back to 0.6, 1.5. Wait, is that right? Yeah. Yeah, that looks good. And now let's hit play again, make sure that it rotates. Yeah, okay, it's doing the opposite of what I wanted, but that's okay. Just put the negative here. Do the opposite thing down here. I guess I was thinking ahead of myself on the other problem. The other thing can be a real problem, so, I mean, you saw it in the editor, so just keep that in mind. If you're running with some weird rotation stuff, that might be your problem. So let's see if this works exactly right now. So now we hit left and we rotate left, right we rotate right, and if we hit forward, you start moving forward, and then we can move a different direction. and we got the little thrusting thing going on. So we already have our basic asteroids movement. So now, what else do we need? Let's add some asteroids. Let's do the asteroids first. So asteroids are basically big spheres, right? So we've got our sphere. We're going to make it bigger. 5, and kind of looks cool with the flattened out there, but you're not going to be able to tell much from here anyway. So our play area is already kind of cramped at our current scale, so I'm going to just move the camera back a little bit. Let's make it -30. Yeah, that gives us a lot more room to work with. So now we got our little ship, and I feel like we need to make the thrust more and the rotation more, so let's do both those things. Let's make the rotation 120, and let's make the thrust 300. See how that plays. Alright, so it's rotating much faster, thrusting much faster. So we don't have a max speed or anything, or max thrust or anything, so that's something that we can add. I'm probably not going to do that just yet, but so we've got, there's our ship, there's our asteroid. Well, it's a sphere. Let's actually call it an asteroid. So, asteroid. So now let's create a script for our asteroid. So what are the parameters that we're going to have for here? So our asteroids are going to be built around rigid bodies as well. So what do? All we need to do is we need a size. So public, I'm going to call it, okay, so let's see. So asteroids, when you destroy them, they become smaller asteroids, right? So how could we best handle that? I'm going to have it be that there's 3 sizes of asteroids. And so we're going to actually represent the size with with an integer. So we'll call this size. And let's see. Yeah, let's just call it size. And what else? We could set up parameters for how big each one is, but I'm just going to start with the size, and we'll just do some ratios, and maybe we'll expose the ratios later as variables. But let's just get this working first. So we're going to default the size to 3. Let's see, 3, 2, 1, and then let's default it to 2. So all we're going to do is on collision enter actually, let's just do a start for things. Let's get them moving first. Start, void, start. We're just going to give them a random direction to move very slowly. So what we'll do is we'll just do add force, rigid body dot add force, and then we will add it, what is it called? Unit vector, random dot inside unit circle or sphere. I want circle. Although add forces requires a 3-dimensional vector. Let's see if this actually will just figure itself out anyway. Let's just see what that does. It's probably going to give me a compile error or something, or nothing. Alright, it worked. Let's actually attach it to our asteroid. Oh, no rigid body. Let's fix that real quick. What is it called? Rigid body. Do not use gravity. Alright, and it's X and Y position you're moving. Okay, so it paid to set this up with the way the camera's facing. So remember at the beginning I decided whether we were doing this top down or sideways, and we did sideways. Well, one of the nice little advantages was we can actually do random.inside unit circle, and we get an XY component that is meaningful. So, and it appears to just work just fine throwing that into add force, which is awesome. So obviously the force is not enough. So let's actually make it times 50. Does that sound good? That sounds good to me. And please tell me I didn't hit that. Okay, good, I didn't. So hit play, and we should get a random direction on the sphere. There we go, it's going in a random direction. We hit OK again, and we should get a different direction. Yep, different direction. That time it didn't get a whole lot of velocity. So maybe I'll make it 100. Because it's not like it will always be full power. Alright, so we have our first part of our script there that gets the asteroids to move around. So secondly, when they collide with things, we want them to break into pieces. So void, what is it called? On collision enter. And for a collision we get a, do we get a collider, or do we get, let me find out. On collision enter. So yeah, we get collision. So collision. So what this is going to do is, if size is greater than 0, let's see. Size is greater than 0, we're going to explode it into multiple smaller pieces. Let's actually go ahead and just do public game object medium asteroid and public game object small asteroid. This will allow us to actually have different models for each if we were going to be fancy with it. So yeah, if size, let's just do one for each state. So size equals 2. We are going to reduce the size. No, we don't reduce the size. We actually are going to destroy this object and create a new one. Yeah, we'll just spawn 2 medium asteroids, and then for each medium asteroid we'll spawn 2 small asteroids. As a matter of fact, let's not make it arbitrary. Let's actually do public int pieces equals 2. So if size equals 2, we're going to do instantiate medium asteroid. And so the trick with this is we don't want the two medium asteroids to immediately collide with each other, so they're going to have to be offset a little bit. What's the best way to handle this? I'm going to do medium asteroid. I need a position, and we want it to not overlap with the other asteroid. We'll just have them separated, and they'll spawn in kind of a predictable pattern at first. It's probably a smart way of doing this, but I'm not going to be using it. So let's actually have a public float spacing. We'll make it 1.0 f by default. That's probably way too much, but so we'll instantiate first asteroid at transform.position minus vector 3. We'll just do it on the x-axis. It's not going to look great at first, but we'll make this look better in a little bit. So vector 3, I guess we do new vector 3, and then we do negative spacing 0, 0. And quaternion rotation is, we'll just do quaternion dot what is it called? Identity. Slow brain night tonight. So, although we're going to do this in a for loop, for int I equals 0, I is less than pieces, I plus plus. Encase these in nice little brackets. So we're going to instantiate it, and then we're going to destroy our game object. And then we need one more thing here. We want to make these things behave like they've retained some of the parent's characteristics. So what I think I'm going to do is I'm just going to transfer the parent's characteristics. So we're going to game object instance equals instantiate as game object. And so instance dot rigid body dot velocity is equal to game, rigid body dot velocity. So yeah, so hopefully this will just work. So I don't have anything to hit it with yet, so let's just hit it with our ship. Oh, there's no medium asteroid. So this one's going to be called large asteroid. And then we're going to duplicate it. We're going to make it smaller. Let's go with 2.5. We'll make it exactly half. Now, this one we're going to call medium asteroid. Asteroid. This word looks very strange to me now. That happens. So we're going to create a duplicate of this. The medium asteroid is actually going to be size 1. So it just goes down by 1. It's just keeping track of state. Pieces will still keep it 2, and spacing will still keep it 1 for right now. So large asteroid, we want this to be medium asteroid, and actually in medium asteroid we'll fill that out too, even though that should never happen for a medium asteroid. So, and we don't have a small one yet, but we'll get to that. So let's just get rid of our medium asteroid. No, delete. Hit play. And we'll just ram it. Alright, cool. Barely was enough spacing for those things, actually. Let's hit play again and see what happens. So we're going to want a little more. Oh, I see. Those things don't have any logic to destroy themselves anyway. So how do we handle this? How do we want to do this? Probably do better implementation later. Alright, so that kind of works. As soon as we have the next size thing here, if size equals 1, probably should have done a case statement for this, but whatever. Same deal, except for this time we do small asteroid. Oh, I see. We're setting them to the exact same position. I'm stupid. Do transfer position plus spacing times I. This is such a stupid hack. We'll have a better solution later. Plus spacing times I. This will be way off center now, but at least they'll be spaced out. So I ram it. Yeah, at least looked like they were trying to space each other out that time. So now we need a small asteroid as well. We're going to duplicate this again. We're going to call it small asteroid. And this one's going to be, we're going to make it 1, 1, and 1. And this one we want to be size 0. And then, kind of set this up weird. I guess I could have just had the next one down. Yeah, I could have set this up better. We'll clean this up later. So this one we want to make into a prefab, delete this, and then we put this in our medium asteroid, and we put this in our large asteroid, and we may as well put it in our small asteroid as well. We're not going to be using it for anything, but it's in there. We're going to rewrite that anyway, but not tonight. So else we blow up the asteroid. So here we go. They're going to just really quickly kill themselves really fast this time, I think. So we'll see what actually happens. Yeah, you saw them for a frame. You probably didn't see them for a single frame on the video, but I saw them for one frame. So we need our spacings to be good. We need our spacings to be good enough. Spacing times I. So let's make the spacing. So for the medium asteroids, for the large asteroids, the spacing should be, let's do 5. Medium asteroids will do 2.5, and small asteroid doesn't matter. So let's see what it does this time. Pop. Alright. Well, it worked. That was kind of odd. I would have expected all of the subcomponents to have the same velocity. Let's try that again. I want to attack it out, take it from the top so that we can actually... Yeah, why do they have separate velocities? I am setting that, right? Instance.rigidbody.velocity equals rigidbody.velocity. Huh. That should have made it so that they would move similarly to their parent. Alright, gonna maneuver around again and just give it a little tap. Yeah, they're moving like in completely separate... Oh god. Alright, so my ship now is rotating on its own. And the reason it's doing that is because we are rotating the ship manually. But the ship can be hit and have a rotation velocity, so we need to get rid of that. So if we go to our player, and we go to... This is something I was going to do before. We want to freeze our rotation, actually. This still means that we can rotate, but it means that it's not going to be using physics for rotation. Ever. So why that one... Why is this one going less... Huh. Not what I would have... That looked more like I expected. Yeah, that doesn't make any sense to me why these things would be going different speeds. I kind of like that they're going different speeds, but that's weird. I mean, the rigid body to velocity should be a constant between here and here. Certainly it's on collision enter. I mean, if I wasn't doing this line, it would just be no velocity, right? Nope, they still had velocity. I guess if you instantiate something, it automatically... Huh, I didn't know about that. I guess if you instantiate from a... I'm not going to say that because that's probably wrong, but this certainly seems like it might be the case. Oh, I didn't save this. Save that. Okay, let's give this another look. Yes, not a great night. Not for my brain, at least. No, why do they have velocities at all? That doesn't make any sense. Oh! That's funny. Alright, so we have our start thing, which adds a force. And that actually is what's happening here. We're getting our random force applied again. So if I change this to... if size equals 2. Alright, let's see what this does now. That's kind of an interesting little artifact of the way we had set this up. So now if I crash into this thing, we get, yeah, completely immobile balls. Alright. Now if we give it the velocities, And if you've played the original, occasionally the asteroids can collide with each other, and occasionally they will even their subcomponents will collide. So that's working. Now that looks way too static still. Although good, it imparted my my velocity when I hit there. So let's do, what are we doing? We're going to add a little extra bump to this. Plus random dot inside unit sphere times let's do times 10. And let's do that for both of these. So this will give us a little bit more randomness. Our positioning is still really bad, but crunch. That kind of worked. Oh, small asteroid probably should have, it does have a rigid body, and it has a sphere collider. And it looked like it wasn't blowing up when it hit something. Oh, did I not? No, the script's on there. Alright, let's see what happens here. So I hit this. Oh, they were working. I think the problem is I need to make sure that these do not have, we're going to freeze position on Z, and that should solve that problem we just had. I'm also going to freeze our player position on Z, and I'm going to save, which I should have done a long time ago. So we have a asteroid. Let's make the ship actually shoot, and then we'll probably call it a night. So let's just add this to our ship script. We're going to go monolithic approach on this. So if input dot get key down, we'll go with space. And we want it down this time because we don't want it to auto fire. So what we're going to do is we're going to public game object bullet public float bullet speed. So what we'll do is we'll just instantiate bullet transform dot position, and we'll make it actually, we'll make a public vector 3 bullet spawn position equals new vector 3, and the default will just make it go in the Z direction a little bit. So is that what we want? Let's just make it a float. This one's just going to offset the position a little bit in the direction of firing, so that it doesn't hit our ship. So the bullets are probably not going to be able to collide with our ship anyway, but I just want to avoid the problem altogether. 1.0f we'll just start with. So transform.position plus transform.forward times bullet spawn position. And then finally, quaternion dot identity, because we don't really care what the rotation is. And then we'll give it a little velocity, or we could put logic in the bullet itself. Yeah, let's just give it a velocity. Game object instance equals instantiate as game object semicolon. Instance dot rigid body dot add force. Transform dot forward times bullet speed. And so we're going to default this to our magic 1000 because it seems pretty good for projectiles so far, at least at the scales that we typically are working with. So let's see what that does. So we're going to need a bullet. Our ship's square, it's going to be a square bullet. So cube, we're going to make the cube very small. 0.2 seems probably pretty good. Let's see how big that is compared to our ship. Yeah, that's perfect. So we're just going to call this bullet. And player ship, we drag our bullet in here. And our bullet itself should have a rigid body that does not use gravity. And if we hit play, this should all just work. So we hit space and we're firing. We hit things. Alright. Alright, very basic game of asteroids with one big asteroid is it's actually basically done. We don't have death situation. We don't have screen wrap, which is something I definitely want to add because that's fun. I even want to do it right where you can see your ship on both sides of the screen at once, which requires us to actually have more than one ship. Which I'm not going to promise that we're going to do that, but it'll at least be an interesting little challenge. I figure this one will probably only take one more episode because we're already this far. Though, depending on speed, we may do 3. And if we do 3, I'm going to do sounded there. We'll flesh it out real good. But, yeah, so I'm going to call it. It's 3 minutes early, but yeah, I'm just going to say that we're done for right now because I can't think of anything offhand that we can fix really quickly. So I'm just going to hit save scene here, and I'm going to do the standard spiel. Give me an email at pushypixels@pushypixels.com if you want to talk with me or have any suggestions for the show or whatever. Love to hear from you guys. And if you have an iOS device or an Android device and you like breakout games and you like this show, you should buy Proton Pulse. Proton Pulse is available on iOS and Android, and it's fun. It's a flashy little 3D breakout game, and it supports the show if you buy it. Anyway, this is Max Moreau, and thank you for joining me for this episode, and good night.